Okay, let's proceed with our example. We are going to analyze the frame. So starting with resolving the resultant. Since we have a distributed load, we need to get the resultant of this rectangular load, which the resultant happens to be at the middle of the distribution. So this is 20 times 4, and this is 80 kilonewtons. And let us now proceed in solving the reactions. At point A, it is a hinge, so there would be a vertical and a horizontal. And then at D, there is a roller, so you have D vertical. So the next thing that we're gonna do is solve now the reactions of the frame. So starting with the summation of forces horizontal equal to 0, to the right positive, to the left negative. So what are the forces along the horizontal plane? You have AH and no other except AH. Therefore, you equate that to 0, and this is now your value of AH. Proceed with the summation of moment about point D equal to 0. So we're gonna have AV as the value for after getting the summation of moment at D. So you have A vertical about point D. It's going to rotate clockwise with that direction upward, so it's clockwise. So since it's clockwise, then we're gonna consider this as positive, and the moment arm is 4. Next is this one, 80. 80 is going to rotate counterclockwise because the direction is downward in relation to dv. In relation to point D, it's going to be negative. So it's 80, and the moment arm is 1/2 of 4. So 1/2 of 4. And this one, since the 100 is clockwise, so you have to consider that as positive 100. No more moment arm because it's already a moment. Okay, let's finalize. You have transposing all the terms except AV to the other side. We will have AV equal to positive 80 times 1/2 of 4 is 2, then minus 100 divided by 4. So A vertical is, it's going to be 80 times 2 minus 100 divided by 4. The value is 15 kilonewtons. So this is your reaction at A. Next is gonna have summation of forces, since there are 3 equations of equilibrium. So we're done with force horizontal and moment. So the last one is force vertical. So equal to 0, and sign convention positive upward, downward negative. So what are the forces on the vertical orientation? We have A vertical, upward positive, and then dv as positive because it's upward. We assume that to be upward, and minus 80 equal to 0. So now, since AV is already 15, and then dv is the unknown, and you have negative 80 equal to 0, let us simplify. Transpose all the terms except dv to the other side. So that's going to be dv equal to positive 80 minus 15. So dv now is, no, that's 65 kilonewtons. So make sure that you got the answers or values of the magnitude correctly. So what we're going to do is we're going to do the checking. So let me just put it in the box. So let's do the checking. How do we do the checking? The same with beams. So since we're done using the summation of force vertical, horizontal, and moment at D, the last thing that we're gonna do is do the summation of moment at A, since we only have 2 points of reaction or 2 points of supports. So since we're done with the other support, then the remaining support, which is A, should be the point where we need to rotate for checking. So clockwise positive and counterclockwise negative. So just in case you're sure if you got it right or not. So here, let's do the summation of moment at A. Rotating AT about point A, it's going to be clockwise. So that's AT times 1/2 of 4. And then this one is 100 clockwise again. So it's positive 100. And this one, it's counterclockwise about point A. So it's negative dV times 4 equal to 0. You have AT times 2 plus 100 minus dV, which is 65, times 4 equal to 0. We're expecting the value of this equation to be 0 to check whether our answers are correct or not. I'm sorry for the background noise. So it's 0 equal to 0. So this is, so all our values are correct.